Hi, I'm Akram. In this video, I'll be explaining to you how we can use EULER's method to approximate the solution IVP. Here, I'll explain how EULER's method works using this hand-drawn graph and table applied to the differential equation. The idea behind EULER's method is to estimate the solution of a differential equation by using the slope at a known point to predict the next point in small steps. These small steps are known as step size, which in this case, I initialize as h. So we begin at the initial condition given here, x0 and y1. So we use the slope given by the differential equation to move forward step by step. So in this case, h is our step size 0.2, and we will pick a point on the black graph, which is 0, 1. From there, we will draw a tangent line to the right in the direction of the graph by step size h, which is 0.2. From here, we will get the new point x value to be 0.2 due to the h step size, and the y value, we will be using this formula here to get the y value. So this yn plus 1 is the y value the new y value that we're trying to find. This yn will be the previous y value of the previous point, which in this case is 1, plus h, which is our step size 0.2, times the IVP solution given here, where the x value will be the new x value, which is 0.2 square plus 1, and this yn value will be the same as this one. So using that, this is how I get the answer, and I'll get 1.2. So the new x value will be 0.2 and the y value will be 1.2. So we repeat this step until our x value reaches 1. So in this case, each step size is 0.2. We will be using 5 steps. So to give better explanation, I will do it once more. So from this new point, we will draw a straight tangent line by h step size 0.2. So with this, our new x value will be 0.2 plus 0.2, which is 0.4. And to find our new approximate y value, we'll be using the same formula previously, and this is the working. 1.2 is our previous y value that we got here, plus 0.2 the step size, times now the x value will be the new x value here, plus 1 over 1.2, which is the previous y approximate value. So we do this until we reach when x equals to 1, and we'll get the approximate y value of 1.909. So with the help of Excel, I'll be solving the IVP solution using the EULER's formula method previously. So first, I initialize the values for the step size. I use 0.1, as using a smaller number will give us a more accurate value to the actual solution. So we are tasked to find the value of y when x equals to 1. So I'll be using EULER's formula and starting when x equals to 0 and y equals to 1. So here, x equals 0, y equals to 1, I will find the function xy. I will use the x value square plus 1 divided by y, which is 1. So moving on, the new x value will be the previous x value plus the step size. And for the y value, to find the new approximate y value, I will be using the previous y value plus the multiplication of step size times the function xy, the previous function xy. So each step, I will be increasing the x value by 0.1 all the way until x equals to 1. And with the help of Excel, I can automatically derive the final approximate y value when x equals to 1, which is 1.91138. And you can see, if I change the step size, for example, from 0.1 to 0.5, you can see that the graph changes accordingly, and the bigger the number, the more steep the slope is, which shows that the accuracy of the approximate value will be less accurate to the actual solution. Now, I will be solving the IVP solution using the general solution method, first order ODE, to get the actual solution value. So first, I will cross multiply and then integrate, and I will get y squared over 2 equals to x cubed over 3 plus x plus c, and rearranging, I will get y squared equals to 2 bracket x cubed over 3 plus x plus c. So now, we use when x equals to 0, y equals to 1 to find the c value, which here, we get half. So you add the c value to the equation to rearrange it so that to make y the subject. Then from here, we need to reject the negative value, and this will be our particular solution. So now we are tasked to find the approximate value of y when x equals to 1. So we just sub in x equals to 1 into the equation, and I get 1.914854216, and round up to 1.915. So the actual value of y when x equals to 1 is 1.915. So now we will be calculating the approximation error from EULER's method by taking the actual value minus the value calculated from the EULER's method. 1.914854216 minus 1.911375, we will get an approximation error of 0.0034. Hence, we can see that the EULER's method only provides solution with an accuracy that is dependent on the step size. So a smaller step size will give a more accurate answer. That's all from our presentation video. I hope you've learned something new. Thank you and have a nice day.